Hi everyone, and we'll be talking today about the DUnitm mini-test framework. Now this is a framework that's really part of the project bundling project. Now that project allows you to create Delphi repositories, version control repositories that allow you to just simply check out the repository when all the components are automatically installed in Delphi for you, and when you close again, they all are unloaded again. It gives you the great advantage of being able to bring new developers on and have them instantly start work. So the purpose of the mini test framework, though, is it is just a standard unit testing framework. The great advantage is that it's just a single PAS file. It's this one here, the mini test framework PAS file, which you can find at my Delphi tips GitHub. So that's the URL there. And so if you want to have a closer look through this wiki here. It takes you all through it. So there's two approaches to using DUnitm. First is we create a simple test run, and that's what we're going to be doing today. Now, simple test run pretty much is just you make a title and a test summary, and then call your test cases in the middle, and that's pretty much it. In fact, standard test runs, which are preferred method, makes that a little bit tidier by allowing you to create a set to hold all your projects, and you can have multiple test runs and run them one after the other, and it allows you to keep the results of those separate. It also makes handling exceptions a little bit easier. Anyway, so let's get started. First off, I've got this project which has three simple functions on it. One is add text or concatenate text, double numbers, and then square root. Now, at the moment, if you type anything in here and click add, it doesn't actually do what we want it to do. It doesn't do anything. This one here, if you do a double, it's obviously not doubling that number. That's just any old random number that's in there. Okay, the reason for that is that here is the unit that has the implementation of those functions in it, and you can see that they're actually not implemented. So what we'll do is we'll use the mini test framework using a TDD pattern, or test-driven development, so that we can create the solution for our project, and be sure that we've pretty well thought of everything, and we'll be able to test on another computer without any effort. So first things first is we've got our test program here. What we want to do is associate our test cases with the thing we're testing. So ideally we want to test use simple functions and have the test cases in this project. So the simplest approach is to create a project group to keep your project and your test project together. So we'll just call this simple functions group. Now we do have to be a bit careful. Let's just go back and make sure we save that in the right spot. Let's save project group, because it doesn't always follow. So yes, it is. So it actually did save in the same place, which was good. When you make a new project, though, you do have to be a bit careful that it actually adds to the right place. So we've now got a project group. Now we want another project, so we're going to add new project, just a console app, and we're going to save that, again being careful to put it in the right spot. Now normally when you have a project with test cases in it, we actually have a subfolder by convention called tests, and that's where we're going to put our test cases. So we want to call this something that relates to what we're testing, so we're going to call that test simple. Yeah, so we're just going to call that test simple functions, if I spell it correctly. So that's our test project. Okay, so what do we need to put in our test project? Well, obviously we're going to need the test framework. So the simplest way to do that, you could get the whole repo if you wanted, the whole Delphi tips repo, but there's other stuff in there they don't need. So let us just take the simplest approach, and we'll say new, add new unit. So let's go off the page a little bit, and we are going to put our test framework into that unit. And because all of the Delphi tips in the repo. All of the functions are actually just a single unit, so you can simply go to there and copy the whole thing and paste it in. So that's adding test framework to your project. So we're going to save that, making sure we put it into the right place, demo unit test, and of course it needs to be called, and I'll just cut and paste this so make sure I get this right. We actually do want to save it as unit test framework. Okay, so now if we go back to our test framework, there's our test framework added in. And of course we also want to add the thing we're testing, which is this set of functions here. So I'm going to add simple functions. So now we've got that function added to our test project. So we test simple functions. So we've got use simple functions and we're add unit test framework added to our cases. Now, so all we have to do to use this is we follow the documentation. Remember, so we're doing a simple run here. So go back to the wiki and scroll down to examples. And we want a simple test run. And essentially all we have to do is put in a title, some functions, our test cases, and a test summary. So let's do that. So a title, and we can call that testing simple functions. And we can have a test summary, and we also don't want the program to exit if we just run it in the debugger, so we'll just put a read line here. Oops, we do a read line. It's probably going to work better. Okay, so now if we run that, we're getting our title and our summary. Obviously we haven't done any tests, so we don't get anything in our result. So what do we need to do? We want to add a test case here. So we want to create a test case that is readable in the code. So first things first, we look at our functions that we want to test, and let's just because it's easier, let's look at this text one first. So we're going to do get concatenation. So let's test that function. So we want to say confirm that test concatenation works as expected, or returns concatenated text, or something like that. Have a descriptive name for your test case procedure. So let's call, no, I don't want sticky keys, Mr. Windows. Okay, so we're going to say get concatenation concatenates text as expected. Okay, that can be our test case. Okay, now, so we just need to make a procedure to call, and we can do it in the DPR. We can put it in a separate unit if you want to, but just for simplicity's sake, we'll do it here. Now, what we want to say, we're going to have a new case that confirm get concatenation concatenates text, which is basically the human readable version of the procedure name. And we're not getting new case. Okay, that was just a test caching issue on my browser. So anyway, right, we're good. So so we're making a new case, and we also want to make a new test. Just say get concatenation adds text successfully. It's the description. So if we're using TDD, test-driven development, what we want to do is follow this pattern of D and AAA. So what we've done is we've described the test that's going to be done. So we've done that. Next we want to make arrangements so this is going to work. So we want to arrange, and in this case we're arranging some string operations. So let's just we'll just do a bit of work here. So we'll go use simple functions dot get concatenation. So we need text and text. So I want to start with a var, and we want to say L start text, and we're going to want some expected outcome, expected, and we're going to want something to hold a result. So the arrangement's going to be that L start text equals start, and we're probably going to need something else as well, so we're going to have some text to add. Okay, so that's what we need. So we're going to equals middle, and now our expectation for this is that the result is going to be L start text plus L text to add. Rightio. So we've done the arrangement. Next we need to act on the arrangement. So here's our action. So we're going to say L result is equal to L start text and L add text. So we're saying that get concatenation, if we start with L start text and we add L text to add, we should get a result which is the same as expected. Okay, so that's our action. Now our assertion, we're going to say that check. Now there's a number of assertions we can make. There's 5 in the mini-test framework. So is equal, is not equal, is true, is false, and check for an exception. So we're going to say in this case, we're going to check that is equal L expected. We're expecting that L expected equals the result, L result. Now we could have a custom message here saying something like that didn't work, but the default behavior in DUnitm is to actually return you a sensible comparison of what you expected and what you got. So there's no actual need to do that. You can also do skipping here as well, so you can actually also skip this test. Now the reason you want to skip something is if when you've got lots more assertions, you might be using the debugger and get to the point where, look, the third assertion isn't working. I just want to debug into it, but I don't want to run all these other assertions which seem to be working. So we can just skip this particular assertion. Now, what that means is why you'd skip instead of just commenting it out is if you, say, got distracted when you're in the process of doing this testing, you might forget that you've commented out the assertions. So if you've commented out the assertions, you could run your tests and find that some of your other tests are now not even run. So the framework will actually give you feedback saying don't forget that you've got these skipped and you can add them back in later. But for this case, we'll just run the normal behavior, which is check that it is equal, and the framework will do the hard work for us and say, hey, this didn't work, and here's the reason why. So if we run that now, what we're expecting is, as we should in a TDD approach, is after you've set up your test, you want the first one to fail. There's a couple of reasons for that, but essentially you want to make sure your test is set up correctly. So you don't want it to accidentally work the first time you're expecting it to not work. we'll do that. So we'll run it, and we can see that when we did our first concatenation adds text successfully, it actually was expecting start middle, but actually returned nothing, which is quite good because we haven't implemented get concatenation yet. So simplicity itself, we'll return a result here. Result equals a text plus a text to add. Now that's an incredibly simple function. There's not a lot can go wrong with that, and our testing should probably reflect that. If we run that, we now get a path because concatenation adds test successfully, and we're happy that the function actually is doing what it's supposed to do. Now, just to go back to our main project and run that again, if we do type in some text in here, we do actually add some text, blah 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 blah, which is what we added. So we can see the test is actually working. But that's not actually enough. What we normally do is, this is the happy path. We probably test a few things. So if what would we expect, for example, if we now add, we'll just tie these up a little bit. So that's our first case. But if we said, we've already got our start text, if we say L start text equals the result of the last time, and then we want to add end, our expectation is now that if we take our start text plus text to add, and that should now work for a second set of test cases, if I've done it right, and I run the test process instead of the main program. Because okay, I've done something wrong there. That's very likely because I've done something wrong in the test case. So of course, forgot to act upon the testing arrangement. So of course, yeah. So again, it was a fault with my arrangement of the test and running of the test, not the actual function. So the function is actually working how it's supposed to. So normally you do a few variants. What if you add blank, for example? So let's do this again, and we'll copy that whole thing again. We could, if we wanted just to give our feedback a little bit better, we can actually say, you can say here, can add adds nothing to text successfully. So if we say here we want is some text, and if we add text to add nothing, we'd expect that the result of that is that there is nothing to add. Okay, so the expected is L start, and if we run that, okay, so we get two pass tests, two of the same test name. So we're going add successfully, another one that says adds nothing to the text. Just give us a bit extra feedback about what the test was we were actually testing that passed. Okay, so that's pretty good. Now, we'd normally have, what if it doesn't work? So have the sad path. So this is the happy path. When it's all working, what should it look like? So the sad path is when it doesn't. What kind of things could go wrong if we did this? Now, in this case, it's a little bit hard to think of a scenario where something could go wrong. So, this will be a little bit artificial, but let's do it anyway. What we would expect is does not add incorrectly. Okay, so we want to be able to say, well, here's what should happen. Well, we know these things should not happen. Again, it's a bit hard to actually think of something that should go wrong in this particular test case. But let's follow the process through. So what we'd expect, for example, is what we would not expect is that this was true. So if we have start text of start and added to the text start middle, we wouldn't expect it to just equal start text. Now, again, a little bit artificial here. So what we can say is check is not equal. How about check not equal that? So in this case, we're doing the sad path. We will not expect it to do this. And if it did, we know we've got a problem. And the other thing that might also be the case is if we started out with this start text. And we would also not expect it to be equal to our text, to the thing we add. So we're expecting that this is not equal, and we should never equal this, but maybe under some strange situation it does happen. But we'd like to pick it up if it did. With the other test cases using numbers, it actually makes a lot more sense, this part, but we're going through the motions. Okay, so now we've got two negative test cases. Does not add incorrectly. Those both work correctly. So I think that's all we can get out of that first function. So our function's working nicely, and we can show that it is we've actually tested it 5 different ways. Okay, so that's looks like a convenient place to stop. So we'll carry on with the next video, where we move on to the next function that we need to look at, which will be the get double. So see you soon.